you today. And I broke it down into each lesson. So it started with what we began with in this class, and that was simply deciding whether something was yes, a function, or no, not a function, okay? So the first question that I have on there for you is the relation shown in the table a function? So the question is a yes or no question. And the way we did it was to make an arrow diagram. So let's go ahead and do that. Remember, the arrow diagram started like this. We did a D for domain, and we did an R for range. Okay, so what numbers would I list under domain? And I'll hand out tickets after the fact, okay? So don't think I'm not going to do that, but because we have video on, I'll wait. Okay, so what numbers are going to go for domain? Go ahead, Marty. What do we got?
2.
Yep.
4.
Yep.
8, 10.
Yes, perfect. So all those first numbers are our domain, which means what? What's our range then?
1, 2, 3.
Yeah, 1, 2, 3, 4. Do I list the 3 again?
No.
I do not. And then I make an arrow diagram according to what it says. It says 2 goes with 1, so I'll make an arrow. And then 4 goes with 2. 6 goes with 3. 8 goes with 4. And 10 goes with 3. Now, my concern is that people are going to get this wrong. But what's the answer to the question now? Is this a function or not a function? Jo Marie, go. It is a function because there's only one arrow coming out of each of the domain, right? Why am I nervous that people are going to get that wrong? Yeah, it's got 2 arrows going to the 3 on this side. But remember, the range side is not what we're concerned about. So this is a yes. This is a function. The words we would use to explain that, right, are each x value has one y value. Because each x value has one y value. Okay? And do you think that you could copy that exact explanation on your test?
Yes.
Yes, okay? If you have the notes, then yeah, that's going to help you with doing explanations for stuff like that. If you don't have the notes, that's going to be a problem, okay? And maybe you're really good at memorizing, but if you're not, that's why we want to use our notes. Okay, good. Number 2 then, same idea. What I want you to notice is that these ones have circles, okay? So we're going to put our domain and range in the circles, but I'm going to let you do that one on your own as a practice. So we'll go back if we need to do that one. So I want you to circle number 2. That one's one for you to do. Okay? I did include on here, even though it's not numbered, graphs. And I want to know which ones are functions and which ones are not functions. So there are 4 graphs, and we got to recall doing that. So what do we do if we're asking about a graph? Go, Emma.
Vertical line test.
That's right, okay, great. We're looking to use the vertical line test. So what that means is we drop a vertical line anywhere on the graph, and how many times can it hit? Once. So this one only hits once. Is there, I could drop one here, it only hits once. Is there anywhere on the first graph that it would hit more than once? So is it a function? Yes, so this is a function. How about the second one going over? Function or no function? Cameron, go. Why not? That's right. Right here. Anywhere on this side, it's going to hit twice, isn't it? So this is not a function. All right? And again, I'm going to leave the bottom 2, okay, for you to do, to practice. So go ahead and circle those bottom 2. Those are for you to practice on. Okay. All right, so far so good? Because that's, if there's only 10 questions on the test and you can get that one right, there's 10% of your test right there. Boom, done. Okay, actually 20, because one of them is a question like this with the numbers and one of them is a graph. So you can get 20% correct just by knowing those two. Okay. All right, let's move on. So down here, I only included 2 because sometimes you don't need extra. You just need to know how to do it and have an example, okay? So the next thing we did was something like this. Mark has a $100 gift card to buy apps for his smartphone. Each week he buys one new app for $4.99. Write an equation that relates the amount left on the card, y, over time x. Okay, so remember, equations look like this. If you see this word, we are looking for y equal mx plus b. And in this chapter, m is our rate, b is our starting amount. Okay, so in this one, which one has to be our rate? The $100 or the $4.99? There's only 2 numbers to choose from. Which one is the rate? Which one's continuing to happen? Go, Domenico. The $4.99. Is he adding $4.99 to his gift card, or is it coming off his gift card?
Coming off.
There. So we got to subtract it. So negative $4.99 really is our rate. That's our M. Which means what has to be our B, our starting value? Go, Emma. 100. Yeah, our B has to be 100. That's how much is on the gift card. And then we bring down everything else. We bring down y equals, we put an x on that and a plus in there, and that's the answer to number 1. There's the equation. Easy peasy. And then how do we make a graph of this? Where do we know for sure our starting dot has to go? Liliana, where's that? 100. So a starting amount means that we got to put that on there. The 100 goes on, it's also known as the y-intercept, remember? And then negative 499x is really our slope. Now we got to have to estimate here, okay? So estimate means we got to go down 499 and write 1. Our slope is, can we round that, do you think, to negative 5 over 1? Would it help us? Okay, so if I'm estimating going down 5 and over 1 each time, it's going to look like this, right? And then you want to draw your line going through that. Okay, so remember, slope is a rise and a run. That's how we do that. And unfortunately, I didn't find very many good ones to practice on with that. But the main thing that I need you guys to know is how to write that equation for that, okay? So let's put a star by number 1 of that one. It is going to ask you to write an equation. The graphs on there are going to be more, they're going to give you the ordered pairs to actually put on there. So far, so good? Bueno, let's go. Turn to the next page. Okay. The next section is section 3.3. Now, this section is one of the sections where the question will be worth multiple points, like 3 and 4 and maybe even 5 points, depending, okay? And so in this section, we have to compare them, so depending on what they're talking about. So it says 2 linear functions are shown. We got an equation here, and we've got a table here. So this first question says, which function has the greater initial value? Okay. How do we find the initial value on an equation? Where is it located? Marty, go. The which one?
It's M.
It's not M. You're thinking rate. It's 2. Okay. So this is where we're confusing, because the next one is going to ask you for rate, okay? So when it says initial value, Remember, when we talk about y equal mx plus b, this guy is the initial value. And so we really have to be careful about reading the question on this part, okay? And m then is going to be the rate or the slope. So in this case, function a's initial value, and I'm just going to put it under here, a's initial value is 2. It's the b value, not next to the x. Does anyone remember how to find the initial value on a table? And this one you can't just see it. Hold on 1 second. Hello. Hi. Ariane? Yep. And Aaron. Okay, yep, I will send them up right now. With Chromebooks. I will send them. Yep, bye. You guys have to go to the media center with the Chromebook. NWEA. Okay, so on here, how do I find the initial value? Go, Glor. That's the rate, okay? So this is why we're going over this, okay? Liliana, go. What? Yeah.
Where x equals 0.
Where x equals 0. So initial value on here is we're looking for where x equals 0. Okay, what if there is no x equals 0?
Go backwards.
Go backwards, right? So which way would 0 be? Would it be after the 4 or before the 1? Yeah, let's go backwards. Before the 1 would be 0. Now we need this value though. So what's the pattern going by here? Yes, so if I go back 2 from -1 and I go back to, what would it be? -3. We know that because this is going this way is going up by 2, right? Each time. So to go backwards, I would have to minus 2. -1 minus 2. -1 minus 2 more would give us -3 here. Okay, so the question is, which function has the greater initial value? Which one is greater, function A or function B? A. Yep. +2 is greater than -3. And there's my greater than symbol just for our notes. That is greater. That one I feel nervous that people are going to get wrong because we spent so much time doing rate, didn't we? Right? Initial value, and now you have an example. And if you have the notes, you can use it, right? Initial value is the B value. Okay, now it also is going to be one that asks you about rate. These are going to be 2 separate questions on your test. All right? If it asks you about the rate, that means now we're looking for M or B. M. So for function A, who can tell me the rate in function A? The rate would be what, Gabriel? That's right. That's our M. And in function B, and I think Marty said this before, how do I find the rate from the table? You told me this before. How do I find a rate from the table? Y2 minus over. Okay, perfect. So the rate from a table, don't forget, is going to be y2 minus y1 over x2 minus x1. Okay, who can tell me the values then for that? So up here, we didn't label it. Which one is x1 and x2 and y1 and y2? Which is which on this one? Continue that answering that question, Marty. What's x1, x2?
x1 is 1.
Yep.
-2 and -1.
That's right. That's right. Okay. So x1, x2, y1, y2. And so when we subtract that, it should be 1 minus -1 for y2 minus y1. And then it should be 2 minus 1 for the bottom. And this is where you're going to want to use your calculator to double check your answer, because 1 minus -1 might not be what you think it's going to be. You might as well complete it. Go.
1. Need 2.
2 over
1,
which equal?
2.
2. So my rate now is opposite, isn't it? They're opposite numbers. So who has the greater rate? Function B has the greater rate. Good. Function B has the greater rate because 2 is greater than -3. Okay, one last part from this section that I couldn't find a very good question for, so I just included it in my own handwriting because it's on your test. How, if I give you a couple of graphs or tables, how do you tell if a function is linear or nonlinear? Emma, go ahead. That's function or not function. I'm thinking linear or nonlinear. So if we know it's a function, how do I determine linear and non? Go.
If the line is constant.
Yes. Okay. So it will be a straight line on a graph, right? And a constant rate of change. That means that will be linear. So any graph that makes a curve, right, is non-linear. It's got to make a nice straight line. Or any table, like when we did our table up here, right, we could see that it was going up by 2 every time. But if it's not making going up by the same amount every time, we know that's going to be non-linear. Okay, questions on this section? No? All right, hold on one second. I'm going to pause the video and make a second one so that we can put it in 2. So give me a second.